Let's start with Summon Mathematics Algebra. So we are doing the compulsory section 5 questions today. So I gave AI my question bank and is grouped like all the questions by topic, and now we are going to go by in this specific order from easy to hard. So let's do one topic at a time. Let's start with topic 1. What is a matrix and what is rank? So I know matrix. A matrix is just a box of number arranged in rows and columns. That's it, nothing scary. So this is just a way of writing numbers and then manipulating them for faster calculations, I guess. And also because we live in a 3D world, so this helps like in vector algebra and all that. So this vector, I don't know what, this matrix has 3 rows and 3 columns. We call it a 3 by 3 matrix. Now what is a rank in plain English? Imagine each row of matrix is an instruction or a direction. Then rank tells you how many of these rows or instructions are actually giving you new information versus how many are just copies or combination of other rows, useless repeats. So basically, if this row is telling you to move two steps into x direction, this is telling you to go 3 steps in y direction, this is telling you to go 4 steps in z direction, right? But if we had like 2 0 0 and 3 3 0, then we could have written it like, I don't know, maybe 5 0 0. I don't know, I'm not sure this rank thing, but I'm just guessing. So formally, but don't worry about memorizing this, just understand rank is the number of linearly independent rows or columns in a matrix. So independent rows are the ones that we cannot derive using the row column operations, as far as I can remember. So linearly independent just means not a scaled copy or a sum of other rows. Okay. Step 3. How do we actually find the rank? The method you need for exam. We use something called row echelon form. This just means we convert the matrix into a staircase shape using row operations, adding subtracting rows from each other until we can count how many non-zero rows are left. That count equals rank. Um, mhm. Row operations allowed. Memorize these 3. You'll use them everywhere. So first is row swapping. Swap 2 rows. So we can do this in matrices. And somehow it doesn't change us the answer, and that is like hilarious to me. I don't know how this thing works. So we can swap 2 rows or 2 columns, and we can multiply a row by a number, the complete row or a column, and we can also like add a multiple of one row to another to scale it up or down. Fine, let's solve a real exam question. So here we have a question. This, find the rank of this matrix. I can see this, but I know you guys probably can't. So this is 2 0 0 0 3 0 and 0 0 4. I guess it's already in row echelon form, no? I don't know. So this one's a gift. It's diagonal matrix. Only the diagonal has non-zero numbers. Everything else is zero. For a diagonal matrix, the rule is dead simple. Rank equals number of non-zero entries on the diagonal. So look at the diagonal. All 3 are non-zero. So the rank is 3. That's the whole question. 2 marks done in 10 seconds once you know the trick. It's funny how we in college are doing like this question for 2 marks. Isn't this funny? Anyway, so step 5, another real question. Let's do this. It's maybe 1 2 3 3 2 1 and 1 1 1. So this is not a diagonal. This is not diagonal matrix, so we must actually do row reduction step by step. Let's start. So operation 1, make the numbers below the first one become 0. So our first target is to make this 0. So for that we can minus 3 times this row from this row. So R2 will turn into R2 minus 3 times R1. So this is subtracting R1. Fine, okay, so take 2 row 2, subtract 3 times row 1 from it. So row 2 was 3 2 1. 3 times row 1 is 3 6 9. 3 6 9. Now new row would be this 0 minus 4 minus 8. This will turn into 0 minus 4 minus 8. Now row 3 can be written as row 3 minus row 1. So if we subtract row 1 from row 3, we will have this 0 minus 1 minus 2. Now we have this. Okay, so our target again was to make this thing 0, then this thing 0. Now look at row 2 and row 3. Notice row 2 and row 3 is row 2 just 4 times row 3? Well, yes. uh, they are the same line, just scale. So let's make row 2 0 using row 3. Okay, so row 2 minus 4 times row 3, we will get row 2 minus 4 times row 3. Simple calculation, we have 0 0 0. Okay, count the non-zero rows because we have nothing left to do. Maybe that's why. So we have two non-zero rows, so the rank is 2. This is actually a little weird, these calculations and this method. Anyways, so the pattern to remember, your cheat method for exam, if it's a diagonal matrix, just count non-zero diagonal entries. Just count non-zero diagonal entries, done. If it's a regular matrix, use row operations to create zeros below the diagonal until you get a staircase. Then count non-zero rows. So did we get a staircase? Like, how is it a staircase? Anyways, so maybe we can like swap these two rows. Then we'll have only few numbers. Something like a staircase. Anyways, so then count non-zero rows. Rule number 1, check in. This topic took about right amount of time to get. If row reduction feels foggy, that's fine. We don't need deep understanding. Just remember, make zeros using row operations. Count what's left standing. I think this topic needs a little bit of practice, and we are done. This was simple, but it was like weird.